Hello, this is Paul from Foresight Tech. In this lecture, we're going to find the area under the parametric curve. Okay, so here is the result. If we have a parametric curve here, and the parameter theta belongs to alpha to beta, and so the area under the curve. Okay, so first, the area under the curve is this way, right? The normal way we do, not use the parametric. And from left integrated to right, and the y dx. Okay, and so if we do substitution, we know substitution is x equals ft, and then what do we do? Y is there, and what is dx? Dx definitely we go to dx dt, right? Okay, the simple way, if we simplify, we just cancel dt, and see is exactly the same, and the integration limits change, of course. The original is AP, and the new integration limit is for t, right? T is from alpha to beta, so it's alpha to beta. However, we have another case. Okay, the second case. See, all the same, but we switch the integration limit. The left is from alpha to beta, but sometimes it's from beta to alpha. Why we do have this? Okay, because the integration direction. Do you remember? And the integration goes to positive. We always do integrate from the left to right, right? However, to parametric curve, alpha does not always look at the left. Alpha does not always corresponding to the left point. Okay, which means what? If the starting point is on the right side, from the right side integrated to the left, you get a negative value. And the area under the curve we need a positive. So how to do? We need to switch the order. Okay, and however, sometimes it's difficult. Okay, sometimes it's difficult to determine the direction. We don't know where is the starting point, starting from the left or starting from the right. We don't know. So the simple way is to this. You simply choose positive. If we do integration, you find the negative, they get the absolute value of the negative, which is positive, right? So positive is the area we need. Okay, and basically we do use this formula. Okay, we do use this formula, and give you one example here. Let me see. This is the area under the one arc of the cycloid. Do you remember the cycloid? So looks like a circle on the top of the circle, right? But it is different. Okay, and let's going to use the formula how to do this question. Okay, so I directly, and the parameter is theta, right? Okay, so I will going to say what is the area under the curve, and I will put it here. Okay, I put it here. Area under the curve is the formula. I directly going to the parameter theta is from 0 to 2 pi, which means this is alpha, this is beta. I don't know the answer is a positive or negative, but I do need the positive, right? It's okay. So you move on to see if what kind of value you get. And here is y. And then here is, do you remember the formula? dx dt. This is not a t, is d theta. And then d theta. If you cancel d theta, means what? Y is the height. Delta x is the width or the base. Okay, and that's exactly the area, the original area. Okay, here the formula. All we need is go from here, the formula. Okay, and then I will going to plug everything. Why we do know? I guess we know. Okay, so then we plug in. What do we have? 0 to 2 pi. Y is r times 1 minus cosine theta. What is dx d theta? So here is 1, here is cosine. So we do have r times 1 minus cosine theta, right? Okay, parenthesis, and then theta. So now we can simplify a little. R is r square. I plug the r square out, which is r square put here, and 0 to 2 pi. And then the inside is a perfect square, 1 minus cosine square, and then d theta. Now what you do, okay, this is integration, and the square, perfect square, we can factor out, right? No, we can spend, okay, r square is here, and the 0 to 2 pi, and then what do we get? We get 1 minus 2 times cosine theta plus cosine square and theta and d theta. So now what to do? Okay, use the fundamental. We do need this and that divided we know, this we know, this don't know, but we do have a way, right? Remember this, the reducing power, right? Okay, is okay, up here is reduce power, reduce the power. So which way we use? We use the power reducing or the half angle formula. Because I put here is a cosine square theta equals, remember this, 1 plus cosine 2 theta over 2, right? So theta formula. So we call it half angle formulas, and then plug that in. So we do have this. R square is here, 0 to 2 pi, and then is 1 minus 2 cosine theta plus. Okay, I put that in here. It's 2, 1 plus cosine 2 theta, and then d theta. Okay, the inside the integrand, we can put the like term together. See, what do we have? We have r square, 0 to 2 pi. This is 1, this is 1 half, is 3 over 2, right? Minus 2 cosine theta. And here is 1 half. Okay, I put here 1 half cosine 2 theta d theta. Now, so each one we have the antiderivative. I directly use the fundamental. This is antiderivative 3 over 2 times theta, and this is minus 2 times sine theta. Okay, this is sine, right? However, this is a chain rule, so be careful. Here should be equal to 1 out of 4. Okay, plus 1 out of 4 sine at 2 theta. And then it's from 0 to 2 pi. Okay, plug all this is special value, and you going to simplify. What do you get? We get 3 pi r squared is the answer. Okay, that's all. Thank you.